Hello, my name is Danielle Gay. I'm a master's student at Texas State University. My research focuses on the occurrence of coyotes and gray foxes across the United States. I use camera traps, also known as game cameras, to study these species. In this video, I'd like to show you how I use camera traps for my research. My cameras are placed in several public city parks around Austin, Texas. The camera locations were chosen at random, and most of them are off-trail, which reduces bias in my sampling as well as the amount of human photos taken. To survey wildlife in Austin city parks, I set a camera to take photos for an entire month, 4 times per year, in January, April, July, and October. At the end of each sampling month, I remove the cameras and download the images to use for my research. Let me show you how a camera trap works. The camera is housed within this unit. The cameras are battery-powered and store their images on an SD memory card. The unit contains a passive infrared sensor, which detects heat and movement. When the sensor is triggered, say by an approaching animal, the camera takes a picture. Camera traps have many settings which allow them to take both photos and videos anytime the infrared sensor is triggered. My cameras are set to take just one photo every 30 seconds if triggered. Pictures have metadata that is stored with the photo, such as the time and date, moon phase, and temperature. To collect wildlife photos, I install a camera trapped to a tree 1 meter off the ground or about knee height. It's important not to place the camera too high. This height gives a wide and close to the ground view of anything that passes the camera, which is necessary for most wildlife species. Even deer can be captured at this height. Sometimes animals get really close to the camera and you only see a part of their body in the frame. My cameras are placed inside a metal case and locked to the tree to avoid vandalism and theft. Once installed on the tree, I record the location, time, and date for my setup, and I'm good to go. I'll see this camera again in 1 month's time. Retrieving the camera is an easy process. I'll simply unlock the camera and take it off the tree. Depending on the length of time the camera spent in the field, some interesting critters may have moved into the lock case and camera unit. I always use caution when removing the camera as I have encountered many types of insects, spiders, scorpions, and even lizards. I'll open the case to turn the camera off and inspect that everything is bug-free. I again record the location, time, date, and head back to the lab with all of my materials. When I get back to the lab, I'll look through the camera's images and sort out any pictures that do not contain wildlife. It is common for cameras to be falsely triggered, which can be caused by vegetation moving in the wind, as well as the sun's light or shadows bouncing off of the ground or vegetation. I will look through the photo folder to remove all of these falsely triggered images. Since I am interested in where coyotes and gray foxes occur and where they do not, I will keep all images of wildlife to use in my research. I use a special database to document which species are present at each camera. This documenting is referred to as photo tagging. Accurate species identification skills are essential for tagging wildlife images. Many wildlife have unique characteristics that allow them to be identified in an image, such as spots and stripes of a bobcat or the ringtail of a raccoon. I have had to learn the unique features of common Austin wildlife to correctly tag photos. The tagging process can be challenging as images of wildlife are not always picture perfect. Many photos contain only a portion of the animal's body, or photos are blurry from the animal moving quickly. I have to be familiar with the species' shape, size, coloration, and even its habits to correctly identify and tag images. Identifying coyotes and gray foxes can also be challenging as they look very similar. Both species have a variable coat of gray, brown, red, white, and black, and they both have a long bushy tail with a black stripe and black tip. Coyotes are the size of a large dog, but lanky in appearance. Gray foxes are about the size of a house cat. In order to differentiate the species in a photograph, I need to pay close attention to distinguishing characteristics such as face shape. Coyotes tend to have a wider snout with a dog-like face, whereas gray foxes' snouts tend to be slimmer and more cat-like in appearance. Adult coyotes are much larger than adult gray foxes. However, height can be hard to determine in a picture. I will look at the length of the animal's legs and tail in relation to its body size. Foxes have much shorter legs, making them closer to the ground. The environment around the animal can help give clues as well. I can sometimes use vegetation height as a way to gauge the animal's height or size. Once all the images are tagged, I can use their information to run statistical models on species occurrence using programs like R. I hope you've enjoyed watching this video and learning more about my camera trapping research.